Okay, the definition of the absolute value of something is its magnitude without its regard to sign or direction. So in numbers, we have signs that are positive or negative. So we forget about that. We're not considering if it's positive or negative. We just want the value of the number. So here's an example. I always think about it. Pretend you're driving to Rosenfeld, let's say it's just 5 kilometers north, versus Gretna, we say it's 5 kilometers south, or whatever. One's positive in a direction sense, one's negative, but that doesn't matter. We just went a distance of 5. We're just considering the distance part of it, not the where the direction of it was. So here we go. This is the symbol. It's called just flat brackets. So the absolute value of 3 is 3. The absolute value of negative 3 is 3. It's just the magnitude of 3. So it's forgetting about the sign, forgetting about the direction. Okay, absolute values are treated like brackets. So we have to do the bracket first. So what is 2 subtract 7? Negative 5. Then what's the absolute value? 5. So inside the brackets first, so 10 subtract 2 is 8. What's the absolute value of 8? 8. Okay, so this one is a little bit different now. My question would be, what's the absolute value of negative 15? 15. Then this is outside of the bracket. So now I'm going to times by negative 1. So this is negative because that's an outside afterthought. Okay, solving equations. So here, what could I have inside the bracket? Well, x could have been 4 because the absolute value of 4 is 4. Or x could have been negative 4. Does that make sense? Because negative 4 absoluted is 4. So I'm treating it like inside the brackets. So inside the brackets, this 2x could have been 10. Or inside the brackets, the 2x could have been a negative 10. Does that make sense on my split? Inside the brackets could have said 10, or inside that bracket part could have been a negative 10. So therefore, x here would be 5, and on this one it would be negative 5. Okay, next split. Draw me 2 split arrows here. Inside the bracket, so inside the bracket is x minus 2. I could have had that just be 5. Or inside the bracket could have been negative 5. So inside the bracket 5, or inside the bracket could have been the negative 5. And then you just solve. So if I add 2, this is 7. And if I add 2, I get negative 3. So there's my 2 answers. Okay, next one's on your own. Go. Good, everyone got it? There's my split. I could have been inside to be an 11 or the inside negative 11. And there's my solutions. Okay, next. This one's different now. I don't want to split it yet. What should I do first? I should move that. So I'm going to add 5. Okay, now I can split this. Okay, you cannot split until you have it alone. So I'm going to say this inside stuff could equal 8, or this inside stuff could equal negative 8. Okay, so isolate and then split. Okay, I'll let you solve that on your own. Okay, so again on this question, you have to isolate first, so I had to add the 21st. Then I'm splitting. The insides could have been the 18 or negative 18. Okay, and then algebra. That's good. Okay, this middle one. So the first step would be I would subtract 5. Then there's something to talk about. What do you think? What do you know about absolutes? Can we absolute something? Like, what's the absolute value of 2? 2. What's the absolute value of negative 2? 2. So what are we noticing? You can't absolute something and then it will end up a negative, right? It doesn't work. Okay, now we need to flip, 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 flip. Almost near the end. This one's called graphing absolute values. Okay, you'll probably see me with this kind of format. This means graph the absolute value of this function. Graph the absolute value of this function. Okay, there's 3 rules. Okay, when we graph functions, we are talking about the absolute value of their heights. We're talking about the heights. When we look at this, we're looking at the heights of the graph, the y values. What happens when you absolute value a positive number? So, for instance, what's the absolute value of 5? 5. So what happened? Nothing. So we'll just say it stays. Let's talk about the number 0. What would happen if you absoluted 0? What would you get? Just 0. So it would stay. Then the third rule would be, what would happen if you absoluted a negative value? So for instance, the absolute value of negative 6. Positive 6. So it changes positive. So that's it. Where does it stay? Where does it change? Okay, so here we go. If I'm going to graph the absolute value of this, it would stay, this section would stay. So I have to overlap it. That would just stay. What else? Oh, this part would stay because it's positive above the x-axis. Then this part of the graph is below, heights that are negative, heights that are negative. So that's all going to change. So for instance, this coordinate 1, -3, where would you want to write it now? It's going to change to the coordinate 1, +3. So does that look like it flipped? You see that reflection? It changed from negative heights to positive heights. You see it? Okay, let's do this one then. So first of all, overlap where this graph should just stay. Overlap which parts would stay. So stay. So on your test, I do need to see an overlap. Okay, so I had those 3 sections that would stay. Now, this section and this section are negative heights, so they are going to turn into positive. So how low am I? 1, 2, 3, 4, 5, 6, 7. Okay, so your final graph should have nothing existing down there anymore, right? It should all be located above. That's the idea with absolutes. And you can't forget this because we do a lot of it in grade 12. Okay, this number 2, graph the absolute value of x minus 5. Well, first of all, I need to know what this is without the absolute symbols. What does this look like when you graph it? Past experience tells you something. What shapes have you ever graphed in math? And you've only learned 2 things, so you have a 50-50 chance. A line or a parabola. Those are the only 2 things you've learned, and it's one of those. It's a line. And we just graphed these the other day, thinking about mx plus b. What do we know? What does this tell me and this tell me? The slope is what then? How many x's do you have? 1, so your slope is 1. But how do you write that as a fraction? Because I like slope to say rise over run. So 1 rise, 1 run. And then what's this -5 all about? The y-intercept. Okay, so when you know those 2 things, you can graph a line. I'm going to draw it very lightly because it's not my graph. It's just my... So I'm going to do a point at -5. I'm going to do this very lightly. And I'm going to go up 1, right 1. Up 1, right 1. I'm going to draw it like dashed because I don't know what I'm all doing yet. Okay, so a lot of this unit is tying in a bunch of your past math that you gotta still remember. Okay, now I'm gonna go to the absolute. So which part stays? What part would change? So anything with a positive height or 0 height stays. And then what happens to negative heights? They would reflect to be positive. Okay, just in case you run into the other thing that you know, y equals x squared. Do you all remember how to graph x squared functions? If you have an x squared, it's a parabola, and what's this movement? Do you remember what to do in that movement again? What do you do on those moves when you graph parabolas? 1, 1, 2, 4, 3, 9. Okay, and lines. You should know how to graph all those two functions, just in case you run into those.